Hello guys and welcome to my channel. In this video, I'm going to be sharing with you on the topic integration and particularly on the idea of volumes of revolution. All right, so I hope you're going to learn a lot from this little discussion. All right, so we are on pure one. That's pure one integration. All right, and like I said, we are mainly focusing on volumes of revolution. And the general thing here is we know that when we have a graph, right, on the axis, so this is the y-axis and this is the x-axis and the origin. And let's say we have a graph, a curve, say like this, and it is defined for x value, say x1 to another value, say x2. So this is a graph, say y is equal to f of x. We know that by integration, we can find the area under the graph, right? And you should also know that we can find through integration the volume of the 3D shape formed when this graph is rotated through 360 degrees about the x-axis. So we are saying that if you rotate this graph about the x-axis, then it will form some kind of a solid, right? So we'll have maybe something like this. So this kind of solid that we will form. All right. So the volume generated can be calculated through integration. All right. So if you rotate through 360 degrees about the x-axis, you find the volume of the solid generated as the pi times the integral from x1 to x2 of y squared with respect to x. So that is how we do it. Okay. And this is a very important, formula. Now, it is also possible that you rotate the graph about the y-axis. All right, so I'm going to give you another example here. If you look here, we've got the y and the x-axis and the origin here. And let's just have a shape, say, this shape. All right, so this is like your y is equal to f of x. And we want to rotate it about the y-axis. So the limits are, this is the origin, but I'll just call this y1 and y2 basically, right? So we've got y1 and y2, and this solid is going to be rotated about the y-axis to form a solid shape. So we know that if we rotate it through 360, we'll form a solid like this one that you can see on the screen. And we can calculate the volume of the solid generated if it's rotated about the y-axis by pi times the integral from y1 up to y2 of x squared, and that's with respect to y. So these two formulas are important when it comes to finding the volume of revolution. Right, so I'm going to be making use of some examples, right? And we're going to start with this one here. It says the diagram shows part of the curve with the equation y is equal to x squared plus 1, and the shaded region enclosed by the curve, the y-axis, and the line y is equal to 5 is rotated through 360 degrees about the y-axis. So they say we should find the volume obtained. All right, so here we are rotating this shape about the y-axis. Okay, so we know that we will form some kind of solid shape and we want to find its volume. All right, so the formula, if we're rotating it about the y-axis, is Vy is equal to pi times the integral from y1 to y2 of x squared, and that's with respect to y. Remember, that's what we had. That's what I gave you right above on here. Right. So, what are the limits? Okay, the limits are well defined in this case. Let me just erase this. And these are from 1 up to 5. So basically, we are integrating. We're saying that the volume is pi times the integral from 1 up to 5, and it's of x squared. Now, the equation is y is equal to x squared plus 1. So x squared made subject would be y minus 1. So we'll put y minus 1 for x squared, and that's with respect to y. You see that? All right, so that means that we can now do the integration, right? So that's going to be pi of half y squared minus y if we do the integration, and the limits are from 1 up to 5, which is pi of, substituting 5, we get 25 over 2 minus 5, and substituting 1, we get a half minus 1. All right, and this becomes pi of, this becomes 12 minus and minus 5 plus 1 is 4, basically. So we get the answer coming out as 8 pi, and that's how we do it here. All right, that's how we answer a question of this kind. All right. All right, so I hope you did understand what we did. All right, so we want to have a few more examples, right? This particular one was where we were integrating with respect to the to the y-axis, right? We want to have another one, right? And I'll scroll down to question, I think let's use this one, okay? Another one where you are rotating about the y-axis. All right, so basically here they say the diagram shows part of the curve y is equal to 6 over x, and the points 1, 6 and 3, 2 lie on the curve. The shaded region is is bounded by the curve and the lines y is equal to 2 and x equals to 1. So they say here, find the volume generated when the shaded region is rotated through 360 degrees about the y-axis. All right, so let's look at that. All right, so we are rotating the shaded region about the y-axis. Now, what's going to happen here is we will form a 3D shape, right? A 3D shape, and it will be like this, okay? Corresponding to this. So it's some kind of 3D shape that we're going to form here, right here. But part of this curve is going to be a cylinder. Okay, I want you to note something here. Let me just erase this so that it's less confusing. When we rotate this um, part of the graph about the y-axis, it will form a 3D shape, but there's an extra volume rather, which happens to be a cylinder, which we do not need. Okay, so what we need is the volume of the solid formed, which is not particularly, or which does not include the cylinder that we end up forming. So we will have to take out of our calculation for volume, the volume of the cylinder, which is a hollow cylinder. It comes out hollow in the end, that we will form. So basically the solid we will form is kind of like this. All right, but it is hollow at the middle, and this hollow cylinder will have to take it away from the total volume. I hope you understand that. So let's do the calculation. Let me remove all this and we get into it. Okay, so basically we're saying for the volume generated, since it's about the y-axis, we will say pi times the integral from the lower y limit, which is 2, to the upper y limit, which is 6. So it's from 2 to 6. All right. So 2 and 6. And remember, we say times x squared. Now, if you look at this equation, if we make x the subject, it becomes 6 over y, which therefore means that x squared is 6 squared, which is 36 over y squared, which is the same as 36y to the negative 2. Right, so we are integrating 36 y to the negative 2 with respect to y to get the volume generated by the curve rotated about the y-axis. But we are going to take away from the volume formed. We're going to take away from it the cylinder generated this cylinder, and the volume of a cylinder is pi r squared h, right? The height, remember that's from 2 to 6, so the height is 4. The radius is 1. So pi times 1 squared times 4, basically. 4 times pi, so sorry, pi r squared h rather. So that's pi times 1 squared times the height is 4. So that's how we're going to find the required volume. So this is going to be pi off, and integrating this will give us minus 36y to the negative 1. All right. And that's from 2 up to 6 minus 4 pi. Okay. And this is going to give us, now if we substitute 6, right, we will get minus 6 minus, if you substitute 2, minus 36 over 2 is minus 18, right? And all this is minus 4 pi. So we basically have on inside here, 18 minus 6 is 12. So we have 12 pi minus 4 pi, and the answer comes out as 8 pi. And that's the answer we get for this question here for 5 marks. That's essentially what we do and how we handle this type of question. So it's very important that you know how to do this. All right. We're going to move on to another one, right? And the next question, I'll scroll down on my worksheet and I'll go to question. All right, which one should this be? I think I'm scrolling way down to question 26. So it's long ways. Now I'm on 19. Okay. And I think I'm here. Question 26 here. So this is another very good question, all right? And I like this one because it also involves, equation of a circle, which is a good thing. So the question here says, the diagram shows the circle with the equation x minus 2 squared plus y squared being equal to 8. The chord AB of the circle intersects the positive y-axis at A and is parallel to the x-axis. Find by calculation the coordinates of A and B. All right. Okay, so um, we know here that the equation of the curve is this, right? And we also been told that there's a chord. Sorry, let me go back to the page. We've also been told that there's a chord AB here. And about AB, they say that the chord AB means the x-axis, it intersects the y-axis at A and is parallel to the x-axis. All right. So they want us to find the coordinates of A and B. So what we're going to do here is we're going to say for the equation x minus 2 squared plus y squared is equal to 8. At A, okay, at the point A, we know that it's on the y-axis where x is 0. So we're going to ask ourselves, if x is 0, then what is y? All right, so I'll say here, when x is 0, what is y? We're substituting 0 into here. So it's 0 minus 2 squared. So that's minus 2 squared plus y squared is equal to 8. So y squared is equal to 8 minus 4, because this basically is 4. So y squared is equal to 4, and y is equal to plus or minus 2. All right, which means that this point is at plus 2, and this point is at minus 2. So we now already know what the coordinates of A are. Okay. Now we can find the other coordinate of B, all right? To say at B, for B, we know that x is equal to positive 2. So therefore, that means that actually it's not x that's equal to positive 2, it's y that's equal to 2, right? If you look here, is the y coordinate. So it's actually y that's equal to 2. So we basically will be having x minus 2 squared, okay, plus 2 squared is equal to 8, which leads to x minus 2 squared is equal to 8 minus 4, if we take this to the right. So x minus 2 squared is equal to 4. So x minus 2 is equal to plus or minus 2 if we square root both sides. So x is equal to 2 plus or minus 2, where x comes out as 2 minus 2, that's 0, or x equals 2 plus 2, which is 4. So we know that x being 0 defines this point, okay, because x is 0 here, but x is equal to the other value, which we got to be 4 here. So this value is 4. So that means to us that the coordinates of B are 4, 2, and those of A are 0, 2. All right, so that's how we do it. So I'll say, therefore, the point A is 0, 2, and the point B is, well, 4, 2. So that's how we do it for this particular question. Right, let's move on to part B, where they now say we should find the volume of revolution when the shaded segment, okay, bounded by the circle and the chord AB is rotated through 360 degrees about the x-axis. Right, so this shaded segment is now being rotated about the y-axis. But I'm sure you understand from the previous question that since this region is not attached to the x-axis, if we rotate it about the x-axis, there's a cylinder which we do not need, that is going to be formed, which we will need to take away from our calculation of the volume generated when this curve, part of the curve, is rotated through the x-axis. So essentially, we will be saying for the volume required, it's pi times the integral from 0 up to 4. These are the limits for x values for A and B, right? Of y squared. Y squared is actually 8 minus x minus 2 squared. So it's of 8 minus x minus 2 squared with respect to x. And from this, we will also subtract the volume of the solid formed, pi r squared h, pi times the radius. The radius will be this, all right, which is 2. So pi times 2 squared times the height. The height would be, and that's from 2 to 0 to 4. So it's actually 4. So that is how we do the calculation of volume, all right? So we will come here and have everything in place for calculation of volume. All right. So that's going to be here, pi of, integrating 8 is 8x, and integrating this, we'll be having minus, and that's of a third of x minus 2 to the power 3, basically. And that's from 0 up to 4, and that's minus 16 pi. All right, so that's going to be pi, and that's off. Substituting 4, that's 32, minus a third of 4 minus 2, that's 2. 2 cubed is 8. So that makes it 8 over 3. So 8 over 3. And that's minus substituting 0. This part becomes 0. And it's 0 minus, and substituting a 0 into here, it becomes minus of minus, so it's a plus, and that's off 4 minus 2, that's 2. 2 cubed 8, so we get 8 over 3 again here, and that's minus 16 pi. So that gives us pi of 32, and here minus 8 over 3 minus 8 over 3 is minus 16 over 3, and that's minus 16 pi. And 32 minus 16 over 3 gives us 80 over 3 of pi minus 16 pi. And if we subtract the 2, okay, we should get 32 over 3 of pi for our final answer here. So that's basically how we do it for this particular question.